we're to solve these simultaneous equations. And so that means at the very end, I'm going to tell him x is this, y is that, and z is something else. So looking at it, I'm going to try and get rid of the z's. So I'm going to take the top two lines and I'm going to leave the top one as it is. And I'm going to change all the signs in the one beneath. That'll get rid of the z's. X, that's plus 4y equals minus 2. And now I am going to take these two lines and again get rid of the z's. So I'm going to multiply the top line by 2. And leave the second one just as it is. Again, that gets rid of the z's, and I'm left at 3x minus 4y equals 10. Now I'm going to take these two, put them together. The y's are actually going to cancel out, which is great. Don't have to do anything. And put 4x is equal to 8. X is 2. If x is 2, well, x plus 4y, so if we go back to that one, x plus 4 times y is equal to minus 2. We now know that x is 2 plus 4y is equal to minus 2. So we're going to subtract 2 from both sides. 4y is equal to minus 4, y is equal to minus 1. So x is that, y is that, and if I go all the way back, maybe to the very first line, or even this line here, it might be the easiest one, x minus y plus z equals 4. We know that x is 2. Sorry, so x is 2. We know that y is minus 1. So we have a minus from here. We know that y is minus 1 plus z equals 4. So that's 3 plus z equals 4. Z equals 1. They're all my solutions, all three. The next question is also a simultaneous equation, but it's one of the, I suppose, trickier ones. We're going to take the easier equation and we're going to isolate the x or the y. In this situation, I think it's easiest to get the y on its own. So 2x plus 1, I'm going to leave where it is. And the y, I'm going to bring over to here, or I'm going to add y to both sides, whatever way you want to say it. But I now have this where the y is isolated completely. Y can be replaced by a 2x plus 1, or y is equal to 2x plus 1. So now, let's go with the more difficult equation. And anywhere I see a y, I'm going to replace it with a 2x plus 1. And hopefully I'll be able to just finish out the question now and tell you what x is and y is. If you need to, you take that to the side and you square it. When you do, you should end up with 4x squared plus 4x plus 1 is equal to 2x squared plus x. Bring it all to one side. 2x squared plus 3x plus 1 equals 0. And you can use the minus b formula or factorize it, whatever you want to do, and you'll end up with x is equal to minus a half and x is equal to minus 1. And if you want to go back then, you know that y is 2 times the x plus a 1. So 2 times the minus a half plus a 1. And then 2 times the minus 1 plus a 1. And there are all my solutions. We were given a function and we were told that x minus 1 and x plus 4 are factors. We have the option of long division Or we also have the option of, if I have factors, I can change them into roots and substitute in. So instead of saying that x minus 1 is a factor, I could say x is equal to 1. And instead of saying x plus 4 is a factor, I'm going to say x is equal to minus 4. Anywhere I have an x, I'm going to sub in the 1. And then anywhere I have an x, I'll sub in the minus 4, and we'll just see what we're left with. So 2 times 1 cubed plus a times 1 squared minus 17 times 1 plus b, and because it's a root, we know it's equal to 0. So that is 2 plus a minus 17 plus b equals 0. So that's a plus b is equal to 15. Looks like I'm going to end up with a simultaneous equation here. I'm going to throw in the minus 4 now. So we have 2 times minus 4 cubed plus a times minus 4 squared minus 17 times minus 4 plus b, and again it's equal to 0. So that is 64, so that's 2 times a minus 64, sorry, plus 16 times a, plus 68, I think, plus b equals 0. 2 times that, minus 128, plus the 16a, plus the 68, plus b equals 0. And we have 16a, and 128, 68, plus b equals 60. And there's a second part of my simultaneous equation. I'm going to put these two lines together. I'm going to change the sign of this line here. So the b's will cancel out. And minus a minus b is equal to minus 15. So that's 15a is equal to 45. So a is equal to 3. And if a is equal to 3, a plus what gives me 15. So 3 plus what gives me 15. B is 12. So I'm after finding out the values of a and b in that situation. Last one for this video is we have a quadratic here and we want to know where the values of x are. So we're going to solve for x where it's less than or equal to 0. So I'm going to use functions to do this. I'm going to sketch this. We know it's going to be a U shape. And we want to find out where the roots are so that we can give a good sketch here. How do you find out the roots? We're going to solve it. So we've got 2x squared plus 7x minus 4 equals 0. Again, solve it whatever way you want. Minus b formula or factorising. You'll end up with minus 4 and a half. Minus 4 is back here and a half is about there. So my sketch looks like this. Something like that. We're looking for where is the graph below or equal to 0. So below or equal to 0 is that. And we can describe that by saying, okay, if you were on the x-axis, you'd have to be between minus 4 and a half you could check out a value between minus 4 and a half and see if you're right or wrong, but I'm going to trust that that's okay.